Hello, this is the Chapter 2 lesson. The basic topic in Chapter 2 is on study designs. Now, study designs is a very complicated, complex subject, and we're only going to be able to touch on the absolute basics here in this chapter. In your epidemiology class, I know you'll spend more time on this topic. In this lesson, we're just going to hit the high points of Chapter 2, and we'll let the readings fill in the details. So first of all, study designs are broken down into two very broad categories. We have observational studies and experimental studies. In an observational study, we're not doing anything to the people that are being observed. We're simply observing them. In an experimental study, we're doing something to the people in a hope to affect the outcome of what happens to the people. Each of these different types of studies is further divided down into different subcategories. Observational studies, we've got like case control studies, cross-sectional surveys, cohort studies, case control studies, and other different types. Experimental, we've got, for instance, a randomized control or a clinical trial. And so the book talks about these different types of studies in more depth. We're just going to kind of hit the basics idea of these different types of studies. Okay. So in an observational study, these are broken down into two subcategories. We've got prospective and retrospective. And the difference between these two is how time is involved. In a prospective study, we look forward into time. We look at what's happening between now and what happens in the future. In a retrospective study, we look back in time. We take a person as they are now, and then we look back in time to see maybe what happened to them in the past. Okay? Now, an advantage of an observational study is that they're relatively easy to conduct. In an observational study, we don't actually do anything to the people. We simply observe what happens to them or what happened to them. But a disadvantage is that they're uncontrolled and not designed to answer a specific research question. And so they're kind of limited in their use, but they are relatively easy to conduct. Okay. So as a first type of observational study is the case report or the case series. And these are observational studies that are done at a single point in time. And so we're not really looking at in the forward or backward. We're just looking at what's happening right now. In a case report, we look at the detailed report of the specific features of a case. So we look at maybe what happens to one specific person, and then look at the details of their particular scenario. In a case series, we systematically review common features of a small number of cases. So instead of focusing on just one specific case, we look at a few cases. In a cross-sectional survey, or to take an example of a cross-sectional survey, let's look at this question. Is there an association between diabetes and cardiovascular disease? Now this abbreviation CVD is something that we're going to see frequently throughout the semester. That again stands for cardiovascular disease. So in a cross-sectional study, we divide our population up into two sections. For instance, we might look at a section of people with diabetes, and then we look at another section, people without diabetes. So that divides our whole population up into two sections. And now within each one of those sections, we look at just those patients with cardiovascular disease. So those would be our cross sections. And then we look at just those people here and just those people here, and compare them. Look for, is there some sort of association between diabetes and cardiovascular disease or not. In a cohort study, first of all, a cohort is a group of individuals who usually meet a set of inclusion criteria at the start of the study. So they're a group of people with some common trait. Maybe they're all of similar age or the same gender, or in general they meet some sort of inclusion criteria. Cohort studies are observational and they're done over time. So we've got two types, prospective and retrospective cohort studies. Now, the book likes to use figures and illustrations that look like this to help illustrate these different types of studies. So let's talk about briefly how to read these types of figures. So this deals with a prospective cohort study. And again, let's look at a question like this. Is there an association between hypertension and cardiovascular disease? And so in these figures, we've got a timeline down here at the bottom. We start at the left and we move to the right, and time increases. So we start off with a cohort of people. Again, that's some sort of it's a group of people that meet some sort of inclusion criteria. And then we break that cohort up into two groups. In this case, the one group is people that have hypertension, and the other is that people that don't have hypertension. And then we observe those people over time. As we move to the right, some of these people are going to develop cardiovascular disease and some people aren't. Likewise down here, some are going to develop cardiovascular disease and some are not. And so we observe this cohort over time, and then we collect data over here. Maybe we collect data in the middle, and so we collect data over time, and then we analyze that data with appropriate statistical techniques. In a retrospective cohort study, the only difference is time. And so in a picture like this, the study starts over here. So we look at a bunch of people, identify whether they have cardiovascular disease or not, and then we look at their medical records or interview them to look at what happened in the past. In the past, have they had hypertension or not? And we record that. And then maybe we look even further back in time to see if they meet our inclusion criteria. Now, some of those people are going to meet it, some people aren't, so we may have to exclude some people. But that's the basic idea behind a retrospective cohort study. We start here, and then we look back, see what happened in the past, and then look back even further, potentially. In a case control study, we have individuals with and without an outcome of interest. Or an outcome of interest may be, for instance, a disease. And so we've got kind of two different types of people in a case control study. We've got the cases, and those are the people that have the outcome of interest. And then the controls are the people that don't have the outcome. So as an example of this, let's look at this question. Is there an association between sleep position and sudden infant death syndrome, or commonly called SIDS? And so this figure here illustrates this idea of a case control study. So here we've got two cases. We've got people who or infants who died of SIDS and infants who did not. So this is a case, and this is our control. And so we start here in time, identifying these two groups, and then we look back into time and look at how those babies slept, whether in the prone position or some other position. And then we collect data from back here and analyze it with appropriate statistical techniques to look for an association between sleep position and whether they were in the case or the control group. Confounding is an important issue, and one that we'll talk more about later on in the semester. Confounding is defined as a distortion of the effect of an exposure or risk factor on the outcome by other characteristics. So in a study, we're often looking for a relationship between a risk factor and an outcome. And oftentimes there's more than one risk factor involved, and so that can create some confusion or some complex issues that we have to deal with. So as an example, let's suppose again we're looking for a relationship between hypertension and cardiovascular disease. So maybe we do a cohort study, we identify a cohort, and then we observe them over time. Look at whether they develop hypertension or not, and then whether or not they develop cardiovascular disease. But there's a lot of time that can occur here over the length of this study, and there may be more than just hypertension that's affecting things. So maybe there's something else that happens in here that affects our outcome of cardiovascular disease or not. And so that something else is what we'd call a confounder. And so we've got to try to account for that in our statistical analysis. And that's where things can get very complicated. Our last type of study is a randomized control trial. And this is an experimental study, where again, an experimental study, the patients are, or we do something to the people to try to affect the outcome. And in a randomized control trial, patients are randomized to receive one of several different comparison treatments. And so maybe we're going to compare two different types of drugs on treating hypertension, for instance, or maybe we're going to compare a drug to a placebo. And so we're going to randomize people, or randomly determine what type of treatment each person is going to receive. Okay. The advantage of this type of trial is that it's the gold standard from a statistical point of view. It minimizes bias and confounding. It's kind of what we really hope to do in a study. But the disadvantage is that it's very expensive, requires extensive monitoring, inclusion criteria can limit generalizability. So it's good, but it's also got its drawbacks. And these are also called clinical trials. And so this illustration here illustrates this idea of a randomized control trial. So we start off with a sample of people, and then maybe we somehow randomly determine whether each one is going to receive the drug that we're testing or a placebo. And then maybe we monitor them in time to determine whether they get the outcome of interest. In this case, we're testing a new drug for efficacy in reducing hyperlipidemia. And so we monitor them over time to determine whether they develop hyperlipidemia or not. We can collect data here and then analyze it to determine, is our new drug any more effective than a placebo. Now, on page 15 of the textbook, they make the point that designing clinical trials can be very complex. Clinical trials are the gold standard, but they're very, very complex. And here's just a few issues involved with that. Refining the study objectives so that it is clear, concise, and answerable. Determining the appropriate participants for the trial. Determining the appropriate outcome variable. Deciding on the appropriate control group. Developing and implementing strict monitoring plans, and so on. So again, the point here is that these clinical trials are the gold standard, but they're very complex and very difficult to do properly. So that's it for a brief overview of Chapter 2. Your assignment now is to read Chapter 2.